Project 5, Atoms, Numbers, and Elements. Introduction. What is the world made of? From stars to grains of salt, everything is made of the same invisible ingredients, atoms. In this project, you will explore chemical elements, how they are organized in the periodic table, and why your body, your food, and even your phone screen are made of molecules created from just a few essential elements. But this is not just a science project. You'll also read the stories of scientists who searched for the invisible, write short stories with atoms as characters, and create your own molecular artwork. Main reading: The Secret Particle. In a corner of the universe, an electron, a particle with a negative electric charge, felt thrilled. I met a positively charged proton, and I couldn't leave its orbit. I got stuck, it shouted. Other electrons looked on in silence. They knew their friend was lucky together. The proton and the electron had formed something important. An atom, the basic unit of matter. As time passed, more electrons joined with protons to form atoms. And when many atoms joined together, they formed stars. Inside very massive stars, under intense pressure, electrons and protons could even become one single particle, a neutron. Inside those stars, that same pressure allowed protons and neutrons to stick together, forming larger atomic nuclei and eventually atoms with orbiting electrons equal in number to their protons. Meanwhile, on Earth, a girl opened a science book, unaware that thousands of atoms were dancing inside her with the same energy that formed the stars. Science, atoms, and elements. Atom, the basic unit of matter made of a nucleus with protons and neutrons and orbiting electrons. Molecule, a group of atoms bonded together. Chemical element, a type of atom. Examples: oxygen O, carbon C, hydrogen H. Periodic table, the organization of elements based on their atomic number and properties. Examples of common elements in everyday life: carbon C, in your body and in food. Oxygen O, in the air you breathe. Iron Fe, in your blood. Sodium Na, and chlorine Cal, in salt. Matter composition. What do a pencil, water, and a banana have in common? They're all made of atoms. Mathematics. Atomic numbers. Number of protons in an atom's nucleus. Atomic weights. Relative mass of an element. Periodic table patterns based on mathematical structure. Simple operations using molecular masses. Charts and diagrams. Element abundance in the earth and the human body. Language arts. Informative text. What is a chemical element? How does the periodic table work? Short story: The journey of a hydrogen atom from space to your glass of water. Written explanation: What elements can you find at home? Glossary of scientific terms: atom, molecule, nucleus, electron, periodic table. Imaginary interview with a scientist like Marie Curie or Dmitry Mendeleev. Art: modeling atoms and molecules using clay or recycled materials. Creative design of an illustrated periodic table. Drawing the most common elements found in your body. Molecular mandala art. Short comic strip. The adventure of the lost atom. Hands-on activities. Build a giant atom model using household materials. Simulate molecules with marbles and sticks. Board game. Atoms and elements cards with symbols and properties. Home research. Which products use sodium, calcium, or iron? Food activity. Classify foods by the elements they contain. Real-life connections. Your body is made of just 4 main elements: carbon, hydrogen, oxygen, and nitrogen 96%. Food contains essential elements: potassium, magnesium, calcium. Phones contain lithium, silicon, gold, and copper. You share atoms with the universe. You are made of stardust. In stars, atoms with multiple protons and neutrons are created under intense pressure. Evaluation. Final product: my atomic book, including a 3D atom model, an artistic periodic table, a short story narrated by an atom, a fact sheet about your favorite element, an infographic titled, "What's in my breakfast?" Evaluation criteria: understanding of basic chemical concepts, accurate use of scientific vocabulary, creativity and clarity in writing and models, active participation in experiments and class discussions.